Right, let's get started with the second half of our online classroom. Number five, robot visual perception. Right, so now we will talk a little bit more about image processing. Okay, so again, the same thing. We have these two sessions. So the first session, I already show you what are the basic things and what are the tools that you need in order to do your first is to drive your sensor in order to acquire the sensor data. And after that, you need to get the sensor data. All those data will be processed into a structured way, whether you need to separate out the RGB data and also the depth data. Then you're using some library to put them together, right? And then you have the ROS wrapper to put everything into order, and also to have all the data stream flow in your topics that ready for you to process for your application. So the next part is, so once you have all this sensor data ready, so what you can do with that and what kind of application you can develop. So I will show you some example for the coming 1 hour. Okay, so the first thing is to take photo, right? But before this, I would like to show you one more example to show you the difference between RGB and also the depth sensor data. So let me enter my robot with TeamViewer. So this is something not written in the slides, but I think it's nice to show you. So just now you see two images. One is the RGB, and another one which is displayed in a image form. You have all the distant value from the data from the sensor to the object. So we have all the point with all the distance, and you arrange the distance and you represent them with the in a monotone. Okay, so in a grayscale. So how the further one is white, and then the nearer one is black. Okay, but how you want to visualize it in a 3D space. Okay, so that is something I want to show you. So I'm going to do this in another way. So I need to like show the 3D model. So first is like I will run. Okay, let me show you the 3D model way. But maybe I need to let me reduce this first so that I have more space to at least run 3 of this. Okay. Okay, to get the model so that I have the 3D model, I run the turtle board sensor. Bring up 3D. Okay. Then I'm going to show you ROS launch turtle board. Okay. So if I combine the data from the image and also from the point cloud, so if I combine these two data, so what you'll get. So this is something I want to show you. A robot model. So this is a robot model. So let me show this, put it in this way so that you can see it in 3D. So first is I show you the image. Okay. So I have this over here. Okay. So so the point cloud look like this. Right. So the point cloud look like this. And because my hand is very near, so can you see like and this is actually the shadow. Okay, so because the infrared, so all the data behind, I mean like it don't have any more data behind. So you have empty space over here because the hand, and then it bounces back here. So you can see shadow behind. So this is the point cloud, right? So and the color actually from the sensor. So the sensor is over here. So the distance, this sensor, so when it is nearer to the sensor, it is red, and so on. It becomes slowly. Just now it's in black and white, but now it's in rainbow color. But what if it's in 3 dimensions? The other point, this point is over here, and so on. So it's in 3 dimension, which is over here. So which means every I will put this color instead of so let me close this, and then I put the register. So this is what I will get. So 3D, and somehow you can see my hand. You can see the curvature. Can you see the curvature? You actually created the 3D shell or the 3D model of the object in front of my wall in my room. And of course, this is a shadow. Yeah, because we don't have distant data. Because your light cannot pass through solid object. This is to visualize the point cloud and how it associates with the color information. Okay, so I hope this example gives you a very good visualization, the data representation in using this interface. Okay, right. Okay, so this top, put this in here. Right. Okay. So the next thing, the first thing I want to show you is how to save or how to take a photo. So take a photo basically is just from your RGB topic. You just save one of the frame. Then you get the take a photo example. Okay. So how to do this? Okay. Let me connect again. Okay, this one I need to run this. One. Then okay. So here in my Ubuntu system, my robot. Okay, so what I need to do is first, again, I need to bring up. So for you, you are going to bring up using this USB cam dash test.launch. For me, I'm doing this, the multi-Astral. Because I have two sensors, I'm using this multi-Astral. Then in order to take a photo, you just need to use one of the sample code that I've written in the example. So I'll show you where is this thing. Let's see. So let's check. If you go to this repository folder, so inside the Vision folder, you have a script and launch file. So launch contain all the launch file to launch certain application. The script is over here, so you want to see the script. So the take photo, we have two. Okay, we have the take photo example and the take photo sub example. Sub example means it will subscribe to a topic to wait for your instruction in order to take the photo, right? But this take photo, once you run it, it will straight away capture the particular frame when this is executed, right? So I show you the first one, okay? And okay, I show you first, then we see that, okay, maybe, okay? So the source code is, you are going to import all the system file and all the things that you need. Over here, you can see it use a CV bridge, which is a open CV bridge, which means we actually have open CV installed in your system when you install ROS. So what ROS do is like it need a bridge between OpenCV and also ROS because they are using different way of handling the data. So how the data is being presented or being handled in OpenCV and in ROS may be different. So you need this bridge to actually establish the communication. Okay, but over here you are not going to do any of this because it's already written nicely in the example. But what you need to do is like later on, if you want to do your own application, you need to understand all these things in order to modify according to your application, right? So what important that you need to change is over here. So you can see like this image topic over here, written image, camera top, RGB image raw. So just now, if you remember how I run or the topic that I use to see my camera feed is I'm using this camera RGB image raw, which is the camera feed from the camera below. Then I have another topic, which is the camera top. Okay, this one is to get the camera feed from the top camera. Okay, and for you, you are supposed to use this topic. You are supposed to use your own topic. So the topic that you need to do, you need to use is it's not the topic that you are going to use is this one. Okay, so we can see the topic. I didn't list. Yes, this one. So the topic that you're going to use is this image USB cam image raw. Okay, this is the one that you're going to use for your case. So you need to, if for your case, you need to open up this source code. Okay, so over here, we raw CD, RC Vision script. Then inside here we have this few example. What you need to do is you need to image some take photo .py. Oops, sorry. Sorry, not image. Since when I use image? Okay, so what you need to do is you need to change here. Okay, so I have a comment out the one below. So this one is the you need to modify this topic into your topic. Okay, the topic, this one, USB cam image raw over here before you run this code, or else it won't get the data because you don't have this camera or camera topic when you run your webcam. Your topic name, you are using a different image topic. So you need to modify here in order for your code to work. Okay, but since I have this camera top, I can run this. So I will run directly from here. I'll run. So now without looking at the camera feed, okay, I just run. Okay, but okay, yes. So I run ROS run, RC home, vision, take photo.py. Okay, so you can see it already saved image. And where is this image? Okay, let me search. It's supposed to be here. Oops, no, this is not. No, not here. It's not here. So I guess it is inside. It is the home, which is the current directory. Let me check. This one, vision, script. Yes, it's over here. So it depends on where you execute the code. Can you see? I execute over here. So you'll save at the current directory, okay, which is this one. So you can see just now I'm taking near to the floor, but now I'm like on top of my robot. So this is me sitting at my chair. So I have this photo taken. So I have this photo. So this is how I take a photo. But of course, if you want to control what is the timing for it to take the photo, you can use this. You can use the second one, which is I already written the example sub. So you can see like it actually wait. Okay, it do nothing until I key in this, the last one. Right, so I say ROS topic publish into take photo. Then what are the things I want to take photo string, and I'm going to give take photo. Right, so I'm going to take this take photo. So if I run this, save image again. Right, so now I have another one. You see? So this is another image. That's now this one over here, and then I have another one. Okay, so this is just to make it easy, because you want a program that listen to a topic, which is over here. I create a topic called take photo. Then once you publish the take photo message, it will start to take. So it seems like you can do a very simple robot application. For example, like you ask the robot to take a photo of you. So you can connect this to your speech interaction. So when the robot recognizes you say take photo or take a photo or anything that related, then the photo will say, okay, you want me to take your photo, 1, 2, 3, smile. Then the robot will capture. Then you will have something like what we call, I always want to do that, a selfie robot that help you selfie. So you don't need to like ask, you know, like in a party, you have friends around, then you want someone to take a photo for you, but you always need to ask someone that is outside the photos. So now if you have a service robot that can take a photo of your group, that will be very nice, right? Okay, so this is how you can use. So by combining this with the speech that you learned last week, you can create some very cool application already by now. Okay, so I show you this. So if you are interested to know how it is done, you can always like have a look, compare the take photo and the take photo sub. Okay, by the way, for the take photo too, if I'm not mistaken, the topic, yeah, it's use this auto image topic, which is I'm not sure what is that. Yeah, because I think one of my collaborators actually written this code. So this auto image topic will select one of the topic from your ROS topic list. Okay, but you can try it out later on if you like. Okay, so for the sub, you can see I actually create an image sub, take photo, subscriber. So I take this, sorry, it's not this one, but this one, listening until you give the instruction, then only start to in the subscriber into your example. Okay, so I show you these two example, and you can combine this with your speech example, and I'm sure you already able to start do some cool application by now by just combining these few example together. Okay. Okay, so this is not the home folder, but the current directory. Okay, the current directory of where you executed the function. So remember, if you want to run this, remember to change the image topic to something that relate to your camera. So if you're using webcam, you need to use the USB webcam. But always check the topic to make sure that the topic available in your raw system. Okay, so the next example I'm going to show you is this cam shift. So cam shift is color tracking here. So for this color tracking, I'm going to stop all this. So you can see I keep my bring up running. So just now I keep my bring up running. If let's say you turn it off, you need to bring up again. So always you need to start your bring up first. Then you need to check what is your image topic because you need to define this. So let me run this back to right, clear this, and also clear this. Okay, right. So all I need to do is just to run this example, ROS launch OpenCV. So I'm using the OpenCV package, app, and then camshift. Okay, then from here, you need to define your topic, right? Okay, so I need to define the topic image. Okay, this one. Okay, for you it's USB camera, right? But for me, I have to do this camera. Okay, okay, I think I better use the one. Oh, okay, so I just use this one. RGB image raw. Okay, so let's see what happens. So you can see a few these things over here. Okay, right. This is the for this it is using this size of this circle. Okay, and okay. So first, for example, okay, I hope this I'm using this look sample. Then yeah, histogram. Okay, so I sample it. Okay, so just now when I select this region, so you will start to analyze. It's not using RGB. I think it's using the HSV. Okay, HSV. So that's why you got this V and S over here. So you're using the HSV volume. Okay, that's why I select display the color histogram of this to a simple it has a lot. Then a lot of time that okay, my wall is still very like how to say clean, quite stable. Okay, and in color tracking, right? But the problem is from the color that is selected. Okay, so you need to know you can detect, and if using the yeah, this will get I think the saturated something that relate to the intensity of the color. Okay, not just this, but I want to show. Okay, good. So let me see. So once you appear, okay, and it is received with a lot of different results, okay, and over here, what makes okay, you can check the original source code in order to find out some result that you want because like over there it has some comment and you can see the algorithm, so you can from there have a better estimation what are the results that appear in the topic and what are the related topic name that you can use. But over here, I just make a wild guess. This track box maybe is something that I want. Okay, right. So what I do is I just sorry. Okay, so maybe I think this track box is something I want. So what I do is I create echo this camshift. No camshift track box this value, which is every so you can see like this is the whole structure. It keeps updating because like you have all the but when I have a very static things, you can see what something very nice is like we have this actually the center of the detected object. Okay, so this to one direction. Can you see what happened to this xy? Can you see the x value? So which means this the center of and then if I pull it up, miss I need to take it back. Okay, take it back. Right. So now the center of the detected object. That is something you can use. What you need to do is you just need to type and you can do wonders with this. For example, one object, then your robot will say, like, okay, it's moving up and down. So follow this object, right? So this is to demonstrate the application of this example. For example, like you want to make a robot that tracks certain color or things that you want the robot to track or move, or track all these things. Yes. So you can use this to get the value of x. And yes, you can. So this is one of the examples that I can show you. Hurry. Okay. So the next thing is face recognition. Okay, face recognition. So, okay. Right. So again, the same thing you bring up to check your image topic, which is you are using this USB one. For me, it's using the camera RGB RAW. Okay. So I have three examples. One is the face detection. Another one is the face recognition, and the last one is people detection. Okay. So what are the different? Face detection is to detect how many faces in one frame or one image, okay, regardless whether you know about this face or not, right? But face recognition is from all these faces, who are they, right? So for example, like you register, this face belongs to this name and that face belongs to this name. So the next time when this person come into the frame, you can detect and recognize the name of this person, right? So these are the different. And for people detection, it don't detect the face, but it detect the whole body. So you need the whole body in order for the detection to work, right? So it no longer find the features from your face, but find the features from your body. So these are the three examples. And for this cascaded classifier is very, very popular and basic for face detection. So let me show you the example. So I run this again, but instead of cam shift, I'm going to use face face detection, right? Face detection dot launch. Okay. Okay. Oops, sorry. And now I need to be on the screen so you can see me now. Okay. So hopefully it's too low. Okay, let me change another topic. It's too low. Okay. I changed to another higher camera. Okay, so this is higher, so you can see my face now. Right. So if I'm further, it can't really see my eye. Okay, but when I'm getting nearer, so you can actually see the location of my eye as well. So I actually guess this algorithm use the eye as one of the important features to detect the face. Okay, but it don't work if okay, so you need to be facing the front in order for it to get detected. And this algorithm can detect multiple faces in this room. So I can only show you one face, but you can try with your family member, a few person together in order for it to get detected like few topics, see what are the output. So you've got various output that you can track, you can obtain from this example. Okay, so a quick run for the recognition. So using the same way by detecting a face, the next thing is image face recognition. No, how come this is not working? I'm not sure. Okay, never mind. I just type it out. Recognition dot launch. Oops. I think I typed. Okay, I'm not sure where, but I think I messed up some. Oh, okay. Yeah. And you can see now become two windows, and I go into my frame. You can see I already trained, which is what you need to do is so you enter the name of this detected. The command prompt will ask you like whether you want to try to be centered to the, and then you can try this with other family member to take a few person, and also you can see the number behind them is the level of the detection. Right, so you can try this. So you can enter a name, any don't have another person to help me to do this, so you can do it right with a family recognition like this. Because previously I already trained myself, so the system already have few of my, so they already like create the database. And always when you restart, okay, you restart, you close down, and you run again. The next time the recognition will work. Okay. Okay. The third one is the people. Okay, the people is something that you want to try, but what I want to say is you need further people detect. I don't know why, but my terminal is acting weird. Detect dot launch. I think something is wrong. Okay. Face. Okay. Okay. So I hope it detect me. So if I move, I can't really see. Yeah, there is an instant that it detected. Okay, so the idea is you need the whole person in the frame in order for it to work. So I need a bigger space in order to demonstrate this, but you got the idea. You can try this later on. So you try to detect, but we have a noise. Apparently, but maybe these features look like a person. So you need the whole person in the frame, especially you can see the very nice. You need to see the whole body appear in the frame. Then only you can do the detection in a more accurate way. So yeah, you need a bigger space in order to do this example. But well, you can try it out later on. Okay, right. So the next is I just want to show you some example which you can't run it because in order for me to demonstrate the application that use the the distance sensor data, which is a depth data, you need to have the equipment. You need to have the sensor that can measure or give you the data, the infrared transceiver, in order for you to get the data, which is you don't have that features in your webcam because the webcam only give you color information. So I'll just show you example that eventually if you have a RGB D sensor, you can try this. So one of the example that which is what follow me, body in front, the volume, and try to, in order to follow the person in front. Okay. So how this thing is, so how it is done is like you try to imagine. So this is the this one is from the top view. Okay, so we have the sensor, which is a robot, is over here, looking in front. So for example, like someone actually entering this box. So you imagine a virtual box. It is going to calculate the point cloud. Okay, the point cloud that appears. So if someone, just now you remember if my hand entered here, so you have a lot of point over here. For example, you imagine if I walk into this region, which is within the sensing area, sensing range of the robot. So I will start to get points on my body or on my leg, right? Is like, what this algorithm do is like it calculate the centroid of all these points, which is the average of the x, right? So that this centroid represent me or the person or the object in this region, the center of this person. So if this center is the lateral and longitudinal distance that you want, then the robot will stop moving. But if it is different, which means that the rotation and, okay, this is annoying. Okay, I need to move out from here in order for this to disappear. It's not disappearing. Hello, here. I'll show you from here. Okay, this is better. From here, you have the control. So I'm using just a P control, which is a gain. So you times the different in X and also the different in Z. So you will control the behavior of the robot tracking the front person. And these are the parameters, also the scale that you want. I mean the P value that you want in order to control the tracking control, the tracking moment, the tracking control. Yes, the control of the tracking. And it is up to you to find the optimum value, something that's big and small, or you're tracking something that go through a narrow passage or some different environment. This value may change, or it need to be changed in order for better tracking performance. Tracking is not very smooth, so you might want to like think of other control method, PID or PD or PI control, in order to make the control smoother. Okay, but of course this is assuming that you have the robot base and also the sensor with vision. But I just do an introduction. Sorry, okay. So I just do an introduction in order for you to try it out later on if you have access to the robots. Okay, so these are how you bring up the robots, bring up the follower, and you can tune the control, so the follower parameter, follower with this code. Okay, but well, I understand that you can try this at home, but just in case that you have the hardware, eventually you know the application for using the point cloud data as well. Right, so with that, I come to the last part of my session today, which is now it's already 12, so I used up 2 hours full. Okay, so the assignment today is for you to try out. So what you need to do is like you combine speech synthesis and also the speech recognition. You put these two together, so your robot can say something and listen to something. So combine that part with today's example, the visual perception, right? To develop an interactive robot vision application. Okay, interactive application using human object detection. So you can use the cam shift for color object detection. You can do recognition, you can do tracking, anything you like with speech interface. So your robot no longer need you to input, but it can for example, I give you an example with the face recognition example, you combine with the speech. So when the robot detects some person, the robot will, for example, greeting. Okay, you greet, good morning, what is the name? Or when the robot detects someone that is not in the database, so then the robot will like, so what is your name? And even if you want to make more interactive, you can do the training interactive. For example, like you can record down the name and so on, but of course, find the example and so on. But just to use the topic, you can actually do a lot, right? You can track, and you can track the object like, okay, I saw a red color ball, and it's moving on the left, moving to the right, moving top, and so on. You can use the robot speech. Okay, and lastly, of course, if you have done the example and you want to discuss with us, feel free to upload to GitHub and show us the video as well. So you can take an interactive video how your application works, like how I just show you. Then we can discuss. Yes. Okay. So just to show you today, I only show you image processing in robot vision and so on. It's very basic things that I show you today, just in 1 hour. For example, we can use some deep learning based for the YOLO. So this is real-time recognition. Can you see real-time? Have different orientation, different. For example, you use not the in Chinese wording or the Japanese wording and so on. So if your label got a bit different, the deep learning based object detection is more robust, different orientation, different sizes, and so on. And also not just deep learning based, you can do like machine. There are a lot of different. For we can do not just object, or in this gesture we do gesture. So we use face and also gesture to detect result eventually. Yeah, lastly, you got the example. Right. Okay. Well, come on. I don't know why it's stuck. Go back. Yeah, this one. So you can see this is the image showing face, but also detected the hand moving as well. So we have a lot of application we can do using OpenCV. So we can also detect like hand, human posture, gesture recognition, so on, and deep learning based subject detection, and also which means like when you can control a robot to grab something, but you don't give the location of that thing. So then also you're using the RGB estimation. Then from there you control your arm for manipulation. So these are all the examples that we have more classes later on. That if you're interested to join, please put down your name in the attendance list in the remark to tell us visual perception classes. Then we can start to arrange for the following more advanced class for you. Yeah, because I only tell you very basic class for this track, because this track is just to introduce to service robot. But if you're interested, we are going to do some arrangement to see if we can actually offer more specific class in speech or vision and so on. First, I can also easily, more convincingly invite some other experts in our community to give you the class. Right. Okay. So with that, thanks a lot for this is the end for today. I'm going to stop the recording and we can have some discussion after this if you would like. Right. So with that, thanks a lot for your joining, and I will see you next week.